Hi everyone, so today we'll be talking about the mole and molar mass. So over here, in chemistry, we actually use this term called the mole, M-O-L-E. And this is to measure a very big number of any sort of particles. So we can talk about atoms, molecules, and ions. So it's something like a word. So like one pair of particles is actually two particles. 1 dozen of particles will be 12 particles, but we don't count particles in 2 and 12, so we count them in a very big number. So this number is known as the mole, which is the Avogadro's number, 6 times 10 to the power of 23. So it's a very big number. So 1 mole is actually 6 times 10 to the power of 23 particles. So mole is 6 times 10 to the power of 23. So let's say we try to answer a question. So this here, a sample of aluminum contains 3 times 10 to the power of 21 particles. How many mole is that? So we know, let's use ratio. So as usual, divide the page into half. So 1 mole of aluminum is equivalent to 6 times 10 to the power of 23 particles. So 1 mole is equivalent to 6 times 10 to the power of 23 particles, right? And then now I want to find out 3 times 10 to the power of 21 particles, right, is how many moles? So if we use ratio, right, we would know that if 1 mole is 6 times 10 to the power of 23 particles, if I have 3 times 10 to the power of 21 particles, that would be equivalent to, I guess, 3 times 10 to the power of 21 divided by 6 times 10 to the power of 23, right, moles. And when I do the math, that I will get 1 over 200, and that would be 0.005 moles. Remembering that I should always put my answers in decimal place. Okay, so that's how we calculate. Let's go through a few more examples, all right? So the next one, we ask how many moles of ammonia molecules are there in 1.5 times 10 to the power of 23 ammonia molecules. So I know that 6 times 10 to the power of 23 particles is equivalent to 1 mole. How do I remember this big number? You can find it on your periodic table at the bottom. Alright, so 6 times 10 to the power of 23 particles is equivalent to 1 mole. So now they are asking if 6 times 10 to the power of 23 particles is 1 mole, 1.5 times 10 to the power of 23 particles, right, is how many moles? Right? How many moles is that? So we can do our ratio, right? And if you know that 6 times 10 to the power of 23 particles is 1 mole, so therefore I can tell that 1.5 times 10 to the power of 23 divided by 6 times 10 to the power of 23, what would that be? Let's see, 1.5 divided by 6, okay, so that's equivalent to 0.25 mole. Now, some of you might be wondering, Mr. Benjamin, which number should I put on top? So always use an example if you have a problem. So let's say, for example, if I have 12 particles, okay, that means I have 1 dozen, correct? So I'm using mole and then dozen. So I have 12 particles is 1 dozen. So then if I have, let's say, 16 particles, right, how many dozen is that? So by ratio, you will know that if I have 12 particles, it's 1 dozen. If I want to find out 16 particles, right, I'll take the 16 divided by 12, right? I'll do 16 divided by 12, and 16 divided by 12 is equals to 1.33 dozen. Okay, so if you ever feel like, alamak, I cannot remember mole and particle is what, just refer back to your dozen and pairs. Okay, all right, next. Okay, so we have hydrogen atoms. So how many hydrogen atoms are there in 2 moles of H2O? So you first must understand that H2O, right, looks something like this, right? From chemical bonding, H2O. So we should know that one H2O has two H atoms. Do we all agree with that? One H2O, two H atoms. Okay? So what happens if I have 1 times 6 times 10 to the power of 23 H2Os? Right? If I have one H2O, I got two hydrogen atoms, but now I got 6 times 10 to the power of 23, one of it I will get, so you guessed it right, 2 times 6 times 10 to the power of 23 H atoms. Right? I just added this one, so I added this one on this side. So now we know that this number, 6 times 10 to the power of 23, Avogadro's number, is actually the number of particles in 1 mole. So I can substitute that with the word mole. So if I got 1 mole of H2O, I actually have 2 moles of H. Right? So basically I just changed the word 6 times 10 to the power of 23 to the word moles because they are the same. 1 mole is 6 times 10 to the power of 23. So now 1 mole of water has 2 moles of H. So the question asks for 2 moles of H2O. So using our simple ratio, this will be 4 moles of H. Okay? Alright, let's look at the next one. So the number of moles, a number of nitrate ion, right, in 3 moles of zinc nitrate. So 1 zinc nitrate, right, would have how many moles of nitrate ions, right? So we see there's a 2 here, right? So 1 zinc nitrate has 2 nitrate ions. Okay? Then remember what I said over there. If I have 1 mole of zinc nitrate, the ratio will say that I actually have 2 moles of nitrate ions. 1 mole of zinc nitrate, 2 moles of nitrate ion. So now they're asking how many nitrate ions are there in 3 moles. So 3 moles of zinc nitrate, I will have a total of, using a ratio, 6 moles of nitrate ions. Alright, so I hope you can practice it a little and see how it goes. Alright, all the best. Thank you.